Hey, good afternoon. In week 7 lecture class, we stopped at set operations and how to represent them using Venn diagrams, and before that, how to show them using set notations. So today we will continue with the same lecture. 2 subtopics were left. We will cover those, but please note that these are not included in your midterm. So whatever we covered in the lecture classes from week 1 to week 7, only those are included. And the scope of your topics is from the lecture notes. Okay, so your sources are 3: book, lecture notes, and your slides. But whatever we cover during the lecture class, only those topics. You can go back, check in the book, look for more exercises, and practice. Okay, so that is the scope of your midterm exam. And also this week, because we didn't have our tutorials in week 1, so our tutorial classes are delayed by 1 week. So in week 1 we had a first lecture class, but the tutorials of those we covered in week 2. Similarly, for week 7 topics, you are going to do your tutorials in this week. Okay, so tutorial classes up to this week, lecture classes till week 7. Okay. This interval notation and then finding union and intersection of more than 2 sets, that is not included in your midterm. Okay. So I will first finish these subtopics, and then I'll recap the main concepts for as a form of revision. Okay, I'll go through the topics that we have covered. If you find any difficulty, if you want me to repeat anything for your midterm, it's like a revision, so you can just stop me there and ask me. Okay. Let's start with the interval notation. This is basically in your sorry. You can represent the range of elements or numbers that are included in your sets on a number line, and you can perform set operation on those intervals as well. So it is just one of the ways to show the elements in a given set and perform union, intersection, and other operations, difference and complement that we covered. And here you need to know about 2 types of brackets. One is your round brackets, and second is square brackets. When you have round brackets like this, the first element is your one extreme of the start, or you can say starting point of the elements that will be included in a given set. And the second element will be the ending point. Okay, so the very last element in the set. Now it will depend on the type of brackets they are enclosed in, whether you will include these particular elements in the set or not. If it is round bracket, if the range of elements is given within the round brackets, these 2 will not be included, so it will be less than and greater than. Okay, and if it is square brackets, then they will be included. How? Let me show you that. Let's say you have the range of the elements in the set is this, and your domain is set of real numbers. How will you write it? In the form of set notation. X belongs to set of real numbers. This is your domain from predicate logic, you should know, such that X is, you will look at what type of bracket it is. It is round bracket, so it is greater than A and it is less than B. So first element, X will be greater than that always, and second element, X will be smaller than that. And because it is round bracket, these 2 will not be included. That is why your symbol will be greater than and less than. If they are given in this format, in this square brackets, then X belongs to set of real numbers such that X is greater than or equal to first extreme, or first the starting point, the starting element A, and it is less than or equal to the second one. Okay, so this is how you will show the range of elements that are included in a given set. Okay, greater than or equal to, less than or equal to when square brackets, greater than and less than when it is round bracket, when you have round brackets. And you can show these on number line. That is why we call it as intervals as well. Before that, let's look at if you have, let's say, one on your left hand side you have round bracket, on your right hand side you have square bracket. How will you, and your domain is set of real numbers, how will you write that? You should know which symbol to use. X is greater than A, then here you have square bracket, it is less than or equal to B. Okay, that is how you will write, and your domain will remain the same because that is how it is given in the question. Let's say you have another example. If square bracket is on your left hand side and round bracket is on your right hand side, here X is greater than or equal to A because square bracket, and it is less than B because of the round bracket, to explain it simply. And when you have, these are the cases when you have finite sets with finite elements. When you have infinity involved, you will look at on which side of the range the infinity is mentioned. Okay, for example, is it like at the starting point, is it on the negative side, or is it on the positive side, or is it at the starting point or at the ending point? So if, let's say, you have the range is given to you something like this and you have round brackets, in that case, and domain is set of real numbers, in that case, how will you show it in the set notation form? X belongs to set of real numbers such that X is greater than A. And here you have infinity, so this is your infinite set with infinite elements. Okay, and if it is like this, then X will be less than B. This will be the range. Okay, you will look at where your infinity is, and then based on that you will write it in the form of set notation. Yeah, these 4 cases of finite and infinite, depending on your type of bracket that is given to you in the question. Based on that, you will determine the range of elements that are included in the sets. And let's also look at the case where you have different types of brackets and infinity is involved. The symbol will be different. The only difference will be the symbol over there. Let's look at this one. Here, how will you represent it? X belongs to set of real numbers or whatever the domain is, such that, now you see over here, it's square bracket, so X is greater than or equal to A. And on the other side, you have infinity, so like this, infinity, so you don't need to mention it. Okay. In case, let's look at the other example as well. This one, X is less than or equal to, because you have your square bracket B, and everything else you will mention X belongs to set of R where blah blah blah, like this. Okay, but this is how you can show the elements that are included in a given set using interval notation, and whether it is a finite set or infinite set. Okay, is it clear? Yes. Question? Okay. All right. Now you can use this information to show the elements or the range on a number line. And you can also perform union, intersection, difference, and complement using the number line. Let's look at this example. Let the universal set be set of real numbers, and let set A equals to, the range is from -1 to 0. We will look at whether these two are involved later on. And then your set B is starting from, or let's look at it now. It's set A is such that x belongs to set of, set A such that x is greater than -1, and it is less than or equal to 0. Okay, so this is how have. And set B, x belongs to set B such that x is greater than or equal to 0, and okay. So then use this information to show it on number line. Let's this is set A. Now you see, so your set A is like this. When the element is not included in the set, you can show it using open circle or a hollow circle. Okay, so this means that this particular element or number is not included. Okay, and when it is included, where is it? X is greater than -1. Sorry, it should start from here. X is less than or equal to 0 means 0 is included, so closed circle or filled circle. Okay, so this hollow circle means -1 is not included in the set. Closed circle or filled circle, this means that this element is included. Okay, so this is representation of set A on number line, range of elements included. For set B, again you have over here that x is greater than or equal to 0, so you see the circle is closed circle. Okay, and it is less than 1. 1 is not included, but you need to show the range. How will you show that it is not included? Open circle. All right, so this is how you can show the elements included in given sets, and then you can also perform set operations like union, intersection, difference, and complement. So the rules you will need to apply the same rules that you have studied in the beginning. Set operations, for example, union. If you take union of two sets, what elements will be included in that? The element that is included in A, that is part of A or B, you will include all of those in the union. So same rule you will apply, you will just show them on number line. Okay. And for intersection, you will only, we know the rule is that when we take intersection, we only include the elements that are shared between the two sets. So same rule will apply, and you will simply show them in the form of the range as a number line, okay, as on the interval. And then for difference, again, you need to remember the rule that you focus on, when you have to find difference of, let's say, B and A, you focus on the first set that is mentioned, and you exclude all the elements of the second set from the first one, and whatever is left in the first set, that you include in the difference. Okay, so for example, let's say if we analyze this one, set A equals 0, right? 0 is the only element. I mean, if we look at it in the form of integers, let's say this is the one, and B is equal to, suppose, let's look at a different example. Let's say set A is equal to 0, 1, and set B is equal to -1, 0, and 1. Now you have to find out the difference. The same rule will apply. Focus on this set. Check whether the elements are shared with set A or not. The elements that are shared, just exclude those from set B. So -1, is it there in set A? No, right? So in the difference, include it. Then 0, is it included in set A? Yeah, so skip it. 1 there, yeah, skip it. So difference of set B and A will be -1. And this you need to show on the number line. Okay? Is it clear? how will you show it on number line? Only -1, so your closed circle. Okay. For your union and intersection, the same thing. Let's look at the solutions here. For union of set A and B, you will look at both of the range of the elements in both the sets, and you will combine all of them, because in union you include all the elements that are present in both the sets, in either of the two sets, I mean. Okay. So if you see over here, an easy way is just focus on the range here and the range here, and then show that on a number line. So 0, this we are taking union of A and B. Union of A and B is that 0 is it included? No, this is the final one that you get, so it is not included, so it means you will show it using open circle. And on the other side, sorry, I encircled a wrong one. This is the one that you have to focus on. And then on the in the other set, this whole range you will include, because in the union you include all the elements. One is not included, you look at the type of bracket and then open circle. So this is the range of elements present in A union B. Similarly, for your intersection, only 0 is shared, so closed circle. Okay. For difference, again, you will your steps to find out the difference will remain the same. Okay. Just show it on your number line. Okay. For complement, for example, here they're taking complement of A. So what is the rule for the elements that need to be present in the complement of a given set? The first thing is you refer to universal set. You need to have a universal set to find the complement of a given set. And how to find the complement? All the elements that are included in the original set, you exclude them from the universal set, and everything else that is present in the universal set, that is included in the complement of that particular set that you have to find the complement of. Okay. And you simply show that on number line. You will check whether the starting range or the ending, the starting element or the ending element, is it included in the set or not. Based on that, you will choose the circle, the type of circle, and then show it on number line. Okay. So for example, for A complement here, because domain is set of real numbers, it means that all sort of numbers, fractions and everything, that is included. So it's easier to show on number line. You cannot show the like individual elements in your simple set form. So it's easier to show on number line. Just check what elements you have to exclude from the complement, and show the range in the form of your number line. Okay. So if we look at set A, the original set was this was the range of set A, that x is greater than -1 and it is less than or equal to 0. In the complement, that that area or those elements included in this range will be excluded. Everything else you will show. For example, let's see if you want. Let's say if you want to show it as a complement. So you will exclude this, and this will be your A complement. Okay, both of these ranges. Okay, so just take opposite of that or just exclude. Okay, is it clear? Interval notation, clear or no? This one? Where? Let me exclude this. B minus A. Why is it, you mean on number line? It is not included. That is why you are showing it with open circle. No, because you have to show it in the, like, you have to show the starting and ending point, because the only, because you are not referring to some universal set, you have to show the range. So you have to enclose it. It is a finite set, that is why. If it is infinite, then you will have your like, you will have your starting point and it will be infinite up to infinity. Do you understand? No? Let's say, because you have to consider both the sets. That is why. If it was only set B, but you cannot find a difference of one set, you have to consider two sets, right? For union, intersection, difference, you have to consider two sets. So you have to show the range for both the sets. So on the number line, you have to show it anyway. You cannot exclude it, because if you include only this one, the range will differ. If you have more advanced calculations, the range will be changed. So you have to show both for set A, for set B and for set A. You have to refer to what was there in the original, the starting and ending point, and then you will determine which one is included and which one is not, and you will show the in the form of the circle. So you will have to show. Okay, doesn't make sense? Go over it. If you still don't understand, you can just ask me. Okay. Yeah. And what else we have? All right. So this is all about interval notations. Any question from this topic? Any other question? No questions? Then I will move on to the last subtopic of this set theory. How to find out union and intersection of more than two sets. In this situation, what you have to consider is that just like you have in your sequences, you have summation notation, your product notation. Similarly, you can represent the union and intersection of more than two sets in this union notation, a big U, and you will have your lower limit, you will have the upper limit. This will tell you the number of sets involved, and you will have some universal set or a bigger set, which of which the subsets will be part of. Okay, how you will show? For example, in your summation, you had something like this. You had your lower limit, let's say this one, and here you had the formula for the summation. What did it mean? You start from the lower limit, it starts from 0, and then you add, and up to the upper limit, like this. So similar notation you use for union and intersection when you have more than two sets. How do you show this? What is the expanded form? You take this, start from the lower limit, and then instead of here you have summation, here you will have union. So these will be subsets of some bigger set. Okay, so this is your first subset, union with the second subset, union with third subset, and then up to the upper limit. Sorry, union and then ellipses. Then up to the upper limit. All of these are subsets, and you are taking union of these subsets. Okay, and the rule is that the I will go through this information first. Given sets A sub 0, A sub 1, A sub 2 up to infinity that are subsets of a universal set, and given a non-negative integer n, means here it should be positive, then how do you explain this, and what is the rule that X belongs to set of universal set such that X belongs to A of A sub I for at least one I. So what does it mean? That the element that should be present in either of these subsets. So same rule for union, okay? It's the same as when you find out union of two sets. This is the rule that the element should be present in either of these subsets, and for intersection the rule will be same, that in your intersection you only include those elements that are shared between the two sets. Similarly, when you are finding intersection of more than two sets, multiple sets, there the element should be present in all of the subsets for which you have to find the intersection. Okay, so X belongs to universal set such that X belongs to A sub I for every I, means for every subset up to starting from the lower limit up to the upper limit. Okay, so your rule for union and intersection is the same. Okay, let's look at this. I have already showed you how you can represent your, what is this notation and what is its expanded form. This is the notation for intersection, this is the expanded form. Okay, so if you have, let's say, what does it mean? The expanded form for this will be, anyone? Like this. Okay, so you are taking union of 5 sets, okay, and these are subsets of some universal set which is a bigger set. Okay, and union, so it means that the elements that are included in these elements, they are either present in first set, second set, third, fourth, fifth. Okay, so same rule. What about this one? How? Yeah. Yeah. Okay, so this is how you will show the intersection of 1, 2, 3, 5 sets starting from the lower limit up to the upper limit, and these are all subsets of some universal set. And what is the rule for the elements? What elements will be included in the intersection of these 5 sets? The elements that are shared between all of these sets. Okay, so those will be included. Again, you will show the range. Okay, so interval notation, you can use the interval notation as well, the concept from there, but you will show the elements in the form of a range. Let's look at the example. Let's say for each positive integer I, let A sub I equals to X belongs to set of real numbers such that X is greater than minus 1 over I, negative 1 over I, and it is less than 1 over I. What does it mean? That you will look at the symbols. Based on that, you will enclose these starting and ending elements in the bracket. So they are not included. It means round brackets. Okay, and this is the range of elements. Elements starting from here, excluding this particular element, till here, excluding. So between these two elements. All right. And now you have to find out the union. So you have to find out union of 3 sets looking at this range. Okay, so what does it mean? That you have 3 sets. It means A1 will be, first you will compute this. It will be minus 1 over 1. Okay, and its ending element will be 1 over 1, because this is your first subset. So this is first set. Second one will be this one minus 1 over 2 and 1 over 2. Then third set, because you have union of 3 sets, so it will be minus 1 over 3 up to 1 over 3. Okay. So these are the elements included in respective sets. Okay. So now you have to find out union of these 3. How can you show it the union in the form of union notation? It will be, you will look at the number of subsets. So you're starting from 1 up to 3, and then you have A of I. Okay. So this is your notation form, and this is the expanded form. And then you will look at the rule for the elements that are included in the union, all the elements that are present in this range, in this range, in this range. So what does it mean? That union of equals to, what is the range? Minus 1, this one, and this one. Okay. Because this equals to, right? So you see, these are, you see this is minus 0.5, this is positive 0.5, this is minus point something, and all of these are smaller than, so all the elements, all of these ranges are included in this one. So this will be your union. Okay. For, let's say you want to find out intersection of the same number of subsets. What will be the range? Again, you will have round brackets, because in the question you have round brackets. So only those elements, range of those elements that are shared between all of these 3 sets. So if you look at this, which range of elements tells shows you that the elements are included in all of these? This. No. If you take minus 1 and 1, the elements from minus 1 up to minus 1 by 2 are not included here. Then if you look at again minus 1 in relation to this subset, these elements are not included here. So you only need to include the elements that are shared, because you are taking intersection. So the range of elements that are present in this one, they are all included in this set as well. Okay. So minus 1 by 3 up to 1 by 3. So all the elements that are present in between these 2 extremes, they are part of A2, and they are also part of A1. Okay. And they are shared among these 3 subsets. So you will include only that one. Okay. Is it clear? So this is the same thing that I just wrote over here. Let's go through it. So union of these 3 sets, you see the interval will be minus 1 up to 1 for intersect, and then you can write it down in your greater than, less than, equal to format. And for intersection, it is this one. Okay. So this is your answer for intersection. And in case of infinity, because we have covered both finite and infinite sets, so same example you can use when you have your, when the upper limit is not given to you, means some final subset is not given to you. The only difference there will be that you will have to consider this infinity. Your starting point will remain the same. Okay. So yeah, that's all for this lecture. Now, do all of you have your laptops or iPads with you, will test out. Give me 1 minute. You will check if the safe mode browser works in your devices or not for your test as practice. So let me just contact Dr. Salia for that. Please wait for 5 minutes. Okay, open your My Times and go to your test 30% section. And then click on there, you will see mock test. This is your, can you see mock test on My Times? Click on that and then you have to, what you need to do is download and configure this SEB mode, your safe browser mode. So download and configure and then install that. Yeah, yes. Can any one of you share your screen here? Okay. Download this configuration.
I did that already.
Already done. How long did it take?
It's just a text file.
Okay, now configuration. Mm. Other students also please download this SEB on your machines, on your devices.
You just need safe browser. Trust us.
Yeah, no, you need it. You need it.
It's not working. I tried opening.
Okay, so both of these students, please, other students, please check, download, and install the configuration for this, say, SEB, and check if it works or not. For what's your name? Yeah. For this student, it's not working. For the other one again, it's crashed. So, but we need to have this browser for your test. So try it and make sure that you have it installed and working somehow. Try it. Yeah, somehow try before your exam. And if many of you are facing problem in this installation and it just crashes, then you can let us know and we will see what we can do before your test. Okay, maybe like this week, anytime by Sunday. Okay, all of you.
Week 7, right?
Hmm.
Week 7 lecture. That's indirect argument proved by contradiction, right? Doesn't have set theory. But in
Mm.
the where is it?
Week 7, I mean set theory we covered in week 7. So week 8, because it was independent learning week, so set theory it is mentioned in week 8, right? So we covered that in week 7 in the lecture
So we have
class.
set theory.
Yeah, we have set theory.
It says that here, it isn't. It's different.
Maybe I will change it. It's all messed up because of the delay in your tutorial classes, because in week 1 we don't have any tutorial classes, so that's why. Yeah. So maybe I will change this to week 7 as well to avoid any confusion. Yeah. Okay. Hmm. How can I check it? Is it working on any of your devices? None of you? Yours working? Then then you can try mock test. Just use the password 123 and try mock test. Try attempting it. Once it is downloaded, then you will install it, and then you will try to do this exam mock test. How I want to open. Yeah. How do you want to do that? So once you install that, then you need to attempt this test after you are done. After it is installed. So it's working in two of the students' laptops. So make sure that it is installed, and then attempt this mock test. That is, I think there are 5 questions. So you're given 10 minutes. Try to attempt the test in your safe exam browser. Okay, it should work. If it is working on his, start downloading now. Beforehand, so install it now. Try installing it now. That is why I wanted to do this practice. Unsupported, retry. Those students on whose laptop it is working, please attempt the test. Mock test, please attempt it. Okay, I see 7 students who have attempted the test. It means it should work fine. So install it beforehand. Install it today and attempt this test, and then it means that it should work on your midterm day as well. So you will use this browser to attempt your actual midterm exam. Is it not? Password is 123 for the mock test. Okay, done. I see. Let me share the screen. Okay, I see 26 students have attempted the test. It means you are able to download and install the configuration. So make sure that those who haven't installed, make sure that you download the browser configuration, everything, and install it before your midterm test. Okay, you will be using this mode for your midterm. I will repeat. Make sure you have it installed on your devices that you will use for the test beforehand. Otherwise, it will take you like long time. It might take long time to for in the installation. Okay, And you will need to close all other browsers except for My Times when you are going to work on this, all right, for your test. I will post this as an announcement on My Times as well. And then those who have not installed now, they will not be able to attempt the mock test. So maybe I'll conduct an online session for you. I will let you know. I'll post it on My Times if you want to attempt the test, if you want to check whether you can actually attempt the test on using this browser or not. All right, I'll post it on My Times. But have it installed before your test. Okay, let's first mark the attendance. Please mark your attendance.